fraction of the variability of returns that is being driven by just the first few factors.
Right.
And we call this the absorption ratio, right? So the idea is that if just a small number of factors is driving a large fraction of the variability of returns, that means that the markets are very compact, very tightly coupled.
Right.
And when the markets are in that state, they're very fragile because shocks travel, quickly and broadly when everything is tightly coupled. So, and then if you think of the converse, if it takes a lot of factors to explain the variability of returns, what that tells us is that risk is diffused across many independent sources. And when, that's the state of the markets, they're much more resilient to shocks. So this measure, which we term the absorption ratio, how much
Right.
risk is being absorbed by these few factors, is a very good indication of a market's fragility. And one of the experiments we did is we looked at all of the major sell-offs in our sample, 1 day sell-offs, 1 month sell-offs, 1 year sell-offs, and we calculated what fraction of those downturns were preceded by a spike in the absorption ratio. And what we found is that almost all of them were. But you have to be careful in how you interpret that. So just because most sell-offs are preceded by a spike in the absorption ratio, it doesn't mean that most spikes are followed by a sell-off. Because what this is capturing is vulnerability to a sell-off, right? To actually have a sell-off, you need two things. You need for the market to be vulnerable, and by that I mean tightly coupled, and then you need some bad news. I think, again, just managing expectations, right?
Mm-hmm.
It's a good thing to do. And and you can say we're in a fragile environment. We should expect that if there's some bad news, our portfolios, could suffer. Hopefully, most likely, this will be a transitory outcome and recover and carry on. We shouldn't panic and think that we've got the wrong asset mix, for example. The alternative is simply to use, again, the statistic Mahalanov's distance and say, here are these different scenarios. One could be recession, stagflation, robust growth, whatever. And for those scenarios, you have values for GDP growth, inflation, the unemployment rate, maybe the slope of the yield curve, right? That's how you're defining these scenarios. Maybe they start out as narratives, but at some point, those narratives need to be translated into numbers.
Right.
So you have a set of numbers for each scenario. And what you can do is say, well, what are the values of those economic variables today? And how distant are each of these scenarios from today's values, right? What is the distance? And by distance, what you're really saying is how unusual would it be to have this scenario unfold versus that scenario? And you can mathematically convert this distance into a probability. So now we have a scientific way of assigning probabilities to scenarios. And you don't have to accept those probabilities, but they should at least be your point of departure. This is what this is a mathematically driven, empirically driven estimate of the likelihoods of all of these different scenarios. So that's, I think that's an important extension of literally, financial turbulence. It's taking the same math and using it to estimate the likelihood of scenarios. What Markowitz did was just genius at the time, 1952. And that's really withstood the test of time. But we don't have to do it that way anymore because we don't have to rely on statistical summaries. We have the computational power to deal with, much more nuanced features of the data, and also, probably more important, more realistic descriptions of our preferences. So Markowitz, mean variance, you can only describe your preferences in terms of mean and variance. And most investors care about thresholds, right? If you breach a particular threshold, circumstances for you change qualitatively. And mean variance can't deal with that. But these, we now have the tools to do that. And so I think we just have to we know how we think about things intuitively. We have way more computational power and way more data than we used to have. We just have to figure out, now that we're not forced to use these statistical shortcuts, we have to figure out how to match our scientific methods with what we know intuitively.